Welcome to Geometry. This is Mr. O'Shea. Today we're going to be covering topic 1.7, which deals all about perimeter, circumference, and area. I do want to make one quick note, guys. Making this in, there's a pretty big storm rolling through, so if you guys hear any thunder or anything like that, sorry if the audio on this is a little bad. We'll make do, though. All right, perimeter. Perimeter is going to be the sum of the lengths. So we're going to add the length, the sum of the lengths of the sides of a polygon. Polygon just meaning any shape. Poly means many, gon is sides, many sides of a shape. Now we can also think of perimeter as just the distance around. So how many feet or meters or yards is it around a shape? So it's the distance around. Now area, on the other hand, you guys obviously learned this a long time ago, but just a quick refresher. Area is the number of square units within a figure. Square units meaning like a 1 foot by 1 foot unit, or a 1 meter by 1 meter unit. 1 inch by 1 inch is a square unit. So when we're talking about area, we're really talking about how many 1 by 1 units can fit inside something. All right, a square. A square has congruent sides, 4 congruent sides, and we'll label the side just S. Now, the formula for area of a square is just going to be S squared. Length times width is what a lot of people say, but if it's S times S, it's just going to be S squared. Now, this one, S is 5, so it's going to be 5 squared. 5 squared is 25. We don't know if it's inches, feet, or something like that, so we're just going to say 25 units. We'll abbreviate U squared. Area is 25 units squared on this one. All right, rectangle. Rectangle has a base and a height. And another quick note on this is that the bottom is always congruent to the top, and the left is congruent to the right. Area of a rectangle is just going to be base times height. Our base is 4 in this case, and our height is 11. So we're going to plug those in. 4 base times height, 11. 4 times 11 will give us 44, but again, we don't know the units, so we're just going to abbreviate U squared. 44 inches squared, or feet squared, or something like that. All right, let's move on to a circle now. A circle that has D10, that means the diameter is 10. Diameter is the length all the way across the circle, and it's a big important thing that the diameter must pass through the center of the circle. Must pass through the center of the circle. But the formula for it is that area equals R squared pi. Now in this specific case, we don't have an R. We have a D. So we have to figure out what R is. And what R is basically called the radius. And the radius is essentially how far is it from the center to any side. So we could go directly up, you could go left, you could go right, it doesn't matter, but it's the distance from the center of the circle to the side. And it's always going to be diameter equals twice your radius. So if the diameter is 10, the radius would have to be 5 in this case. All right, so we calculated radius, now we're going to go ahead and plug it in. It's R squared, so it's really 5 squared times pi. 5 squared is 25, so our answer will be area equals 25 pi. We don't know the units, so let's just say units squared. Area equals 25 pi units squared. You guys do not have to turn this into 25 times 3.14 and give me an answer that's close to 75. I would prefer it. It's more accurate if you leave it as 25 pi. All right, so quick example here. Your pool is 15 feet wide and 20 feet long with a 3-foot deck around it. So I'm going to start off by really always drawing these out. So you got a 15-foot wide pool, 20 feet long. You want to build a fence around it of deck. How much fencing do you need? All right. Well, here's your pool. It's like we said, 15 feet long. I'm sorry, 15 feet wide and 20 feet long. Let's kind of abbreviate those in there. And it's got a 3-foot deck around it. All right, so you've basically got this quick little deck all the way around the outside of it. Let's just kind of jot that down real quick. All right, I like the visual because it helps me in thinking about how long something is. How much fencing do we need? Well, that's going to be talking about perimeter. What's the perimeter of the outside of this shape? Well, we've got 3 feet of deck here and 15 feet of pool plus another 3 feet of deck there. So our top length is going to be 15 plus 3 plus 3, which is 21 feet, I believe. And my length is going to be 3 feet of deck plus 20 feet of pool plus another 3 feet of deck. And that's 3 plus 20 plus 3, which is 26 feet. So we know the top was 21 around the fence. I'm sorry, the fence would have to be 21 feet on the top. The fence would also have to be 26 feet on the side. So perimeter is going to be the top, 21, plus the side, 26, plus the bottom, 21, plus the other side, 26, which gives us a grand total of 94 feet. So the perimeter of your fence would have to be 94 feet. Example B, find the circumference and area of each circle. So we know that the diameter is 12 inches. You guys got to think of circumference as the same thing as perimeter, really. It's the distance around the outside of a circle. We've got a formula for that. Circumference equals, for a circle, d times pi, diameter times pi. Now, diameter, we also said we could relate that to radius. So it might be d times pi, or you can use 2r times pi, because diameter is twice your radius. So you can use either one, it's perfectly fine. All right, in this case, we have diameter, so we're going to use the d pi one. So circumference equals diameter 12 pi, so that's d pi 12 pi. And it's inches, so it's 12 pi inches. And area of a circle, area is r squared pi. We don't have r, but we could calculate it. R is going to be half your diameter, so it's going to be 6 squared pi. 6 squared is 36, so your area is 36 pi inches squared. Area is always units squared. All right, find the circumference and area if the radius is 18. Well, circumference equals, we're going to use the radius version this time, 2r pi. So that's going to be 2 times your radius, which is 18, times pi, which means it's just 36 pi. The unit is meters. So circumference, the perimeter around it, is 36 pi meters. And area is going to be r squared pi. So we're going to plug in what we have. It's 18 squared times pi. 18 squared, a little bigger number here. We've got 324 pi meters squared. 324 pi meters squared. All right, find circumference and area if the diameter is 10 feet. So circumference is going to be diameter times pi, which is 10 times pi, and that's 10 pi feet. So circumference is 10 pi feet. And the area is r squared pi. Remember, radius is half your diameter, so it's going to be 5 squared pi. 5 squared is 25, so it'll be 25 pi feet squared. Area is 25 pi feet squared. Okay, go on to a little different here. Let's find the perimeter and area of each rectangle, given base and height. All right, so we've got base of 3 feet, height of 25 inches. Area equals base times height. Now, if we did this example and we did 3 times 25, we would get 75 something. We don't know what it would be, so we got to convert these so that they have the same units. 3 feet, we can turn that into inches. 3 feet, there's 12 inches in a foot, so 3 times 12 goes 36 inches. Now we've got both units being the same, inches and inches, so now we can actually multiply these. 36, which is our base, times 25, which is our height. 36 times 25 will give us a grand total of 900 inches squared. And our perimeter is going to be our top 36 plus our side 25 plus the bottom 36 plus the other side 25 for a total of 122 inches. All right, next one. Same deal. Got base is 4 yards, height is 102 inches. We cannot do 4 times 102 because we wouldn't know what our units would be. So we got to convert one of them. I'm going to take 4 yards. And I know there's 3 feet in a yard, so I could do 3 feet times 4 yards, which would give us 12 feet. That means 4 yards is really 12 feet. And feet and inches are still not there, so I can't say 12 feet and 102 inches. So I got to convert the feet into inches. I know there's 12 inches in a foot, so 12 feet times 12 inches would be 144 inches, which is good. Now I've got inches and inches, so I can actually go ahead with this problem. Area equals base times height. In this case, our base is 144 inches, not 4 yards. We want to use the same unit of measure. So 144 times 102 is going to give us a total of 14,688 inches squared. Your area of this shape would be 14,688. So now let's go on to the circumference. Oh wait, nope, we're not dealing with a circle, so it's actually going to be called our perimeter. Circumference and perimeter is really kind of the distance around, so it's really the same thing. All right, perimeter is the top 144 plus the side 102 plus the bottom 144 plus the other side 102. Add up all the side lengths, which will give us a grand total of 492 inches. 492 inches. All right, example D. This time around, we're designing a banner to hang in the Commons to advertise for homecoming. The banner will be 4 feet wide by 2 yards high. How much material do we need? So really we're asking how big does this piece of paper have to be? How much are we buying? Now when you buy material, it's going to charge you for the area of it. Area is base times height, so in this example we could just do 4 times 2. 4 times 2, which would give us 8. But we don't know what the 8 is. Is it feet? Is it yards? Well, we don't know. So we actually can't do just 4 times 2. We have to make sure that the feet and the yards are in the same unit of measure. Now I can convert feet into yards and yards into feet. So the quick way to do this would be to know that 2 yards is really 6 feet because there's 3 feet in every yard. So I did 2 yards times 3 feet and gave us a grand total of 6 feet. Now we can do base 4 times height, which is really going to use 6. So it's 24 feet squared. Got to make sure that your base and your height have the same unit of measure. All right, postulate 1-9. This is a time-saving one. If 2 figures are congruent, let's abbreviate that. If 2 figures are congruent, then their areas are equal. Hopefully this makes sense. Again, like I said, this is just a time-saving postulate. If you prove that one area is something, you can just automatically, you don't have to prove the other area is something if they're congruent. Postulate 1-10, one that we will actually use a lot more frequently. The area of a region is the sum of the areas of its non-overlapping non-overlapping. It's a huge key here. It's non-overlapping, so areas can't kind of over-touch each other. It's the sum of the non-overlapping parts. So we got to add up all the different sections to get the grand area. So we got an example here. Find the area of this figure. Note it's not drawn to scale. It's hugely important. You guys will see this a lot in geometry. Things are not drawn to scale, so you can't just kind of eyeball it and say, oh, that looks right. So the top, I'm just going to go ahead and mark my things that are congruent. If the top is 6, I look for the other parts that have 2 dashes, and that's 6. And all the 1 dash marks means that it's 2 inches. I don't know the formula for area for a shape like this, so I got to split it up into smaller shapes that I could do. I see a lot of rectangles here, so I'm just going to go ahead and draw some imaginary rectangles in. Now I've got 3 sections that look like squares and rectangles, and I know the areas of those. So I'm going to calculate the area of the first shape. That's going to be length, which is 6, times base, which is 2. 6 times 2 is 12 inches squared. So my first one was 6 times 2, which is 12 inches squared. My second one, it's going to be, what is that length? I don't know. But I do know that this side is 2 plus another 2, so that's going to be 4, times the base, which is 2. 4 times 2 is 8. 8 inches squared for area section number 2. We'll call that area 2. And I have a third section there that I got to calculate. A3. A3 is also a square, so we can do base times height. Base is 2, and height is 2, so it'll be 2 times 2, which will give us 4 inches squared. Now that postulate 1-10 states that the area of the big figure is just the sum of all the regions, so the total area is, all I've got to do is add these up. 12 plus 8 plus 4 will give us 24 inches squared. The area of that oddly shaped figure was 24 inches squared. Alright, please bring any questions that you might have to class, and I will see you all soon.